Hello, everyone. Good morning, afternoon, and evening. Dear authors and invited guests, welcome to Technical Session 7E. My name is Amog Dhamdere, and I will be moderating this session. On behalf of the Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 11th International Congress on Information and Communication Technology, ICICT 2026. The 11th edition of the conference is being held in hybrid mode. The physical event was held in London, and the virtual event is scheduled on Zoom through the 25th and 27th of February 2026. I hope all of you will all of you will enjoy the knowledgeable and interactive sessions we have throughout the day. In this particular session, we will have 6 presentations, and each presenter will be given 12 minutes to present and 3 minutes for questions and answers. On the completion of 10 minutes, I will be raising a gentle reminder. There is another request to all the participants that all of you please stay connected with us until the closing remarks are given. And if you have any queries or updates, you can write it to me in the chat box. Just before we start with our session, I would like to introduce our session chair for today. So our session chair for today is Dr. Shafi Pathan. He is the principal at Anjumani Islam's M.H. Sabu Siddiq College of Engineering, Baikala, in Mumbai, India. He has 24 years of academic experience. He has authored 5 books, contributed a book chapter, and presented 39 research papers in national and international journals and conferences. His research interests include machine learning, deep learning, IoT, network, and information security as well. Sir, we welcome you, and I request you to give us your opening remarks.
Thank you very much, Amog and all the team. First of all, I'm really thankful to organizer for considering me a session chair for this event. For any conference or any intellectual gathering where people are meeting, it is always not the case that we are seeing, we are judging, we are witnessing whatever research is going on. But at the same time, for a person, for a session chair or the person who is will be in the system, he is also getting out of getting something out of it, like maybe whatever the things which are going. Most of the times whenever conference we are reviewing the paper, it is said that it is a peer review. What is the purpose, what is the meaning of peer review? Peer review means a review by the person who is working in the same domain. So learning from the domain always happens with being a session chair. So I'm really thankful to organizers in this International Conference on Information and Communication Technology for considering me as a session chair for this particular event. And I'm really expecting, or I'm considering, I'm hoping that it will be a great learning experience for me at the same time. So thank you, Amog, and thank you, the team.
Very well said, sir, and you're very welcome. So we can now begin with our presentations for today. So our first presenter for today is Fuad Aleskarov from the HSE University in Russia. And the title of the paper is A Comprehensive Mathematical Model for the Development of the Quality of Living Conditions in the Regions of a Country. So I request you to kindly unmute yourself and start presenting.
So thank you very much for invitation. Thank you very much for possibility to present the paper. How can I switch and present to my presentation?
So there would be an option to share your screen in the bottom.
Yes, I already sent the request.
Well, you can now do it.
Okay, yes, yeah. Here we are. Can you see my presentation?
Yes, sir, your presentation is visible. You can start.
Great. Thank you very much again. And it is my great pleasure and honor to give a paper on this very conference. Here are the list of my co-authors. Some of them are, they join us via Zoom. So the very idea of the work is that, you see, the administrative bodies, you see, confront with so many problems in their activity and they have limited resources. So how to solve these problems need the development of strategy for identifying the priority of the problems. And we have very serious technological solutions, rather wide, in which we have models to analyzing the quality of living conditions in the region, in settlements, in rural places, etc. And then we might stimulate, and this is the basis of the models, simulate scenarios for the development of subsystem, for instance, roads, houses, etc., and choose the optimal and present this very information using these tables, graph, and cartograms. Everything is based on the hierarchical system of models and on different levels of activity of the region. I mean, not only activity, but living conditions of the region. And then these very models are aggregated. We apply these very models with this very system. In fact, it's consulting system for 11 regions, 17 cities in Russia, and 2 cities abroad. So we collect the data on the basis of districts and settlements. Then we have these groups of primary indicators, which are divided into three blocks, sorry. Infrastructure of districts, education, development of education, medical care and recreation systems, quality of housing, service sectors, and public order, and macroeconomic indicators characterizing the socio-economic situation of districts and urban districts and municipal districts as a whole. Then we switch this very information, convert this information into the rank form to have more stable solutions, and then present all these initial data, 3 blocks of initial data in cartographic form. And then we aggregate this very thing, generally using very different rules. In particular, we use this leximin rule or lexicographic rule, in which it's very important part of the story because let me tell you in this form, you see that we cannot make an average, for instance, or even weighted average, because then in this averaging, the low values of criteria are compensated by high values. So we use here the lexicographic models. Then we take these undominated alternatives and one by one exclude them into from the set and rank all these very alternatives, and then we normalize these ranks in this very form. So this is for Republic of Sakha-Yakutia. It is east of far east of Russia. For instance, these are the regions are colored by on the basis of hospital care, 1 hour of accessibility. Green means very good. Light green is also good. Yellow is so-so, and red is not so good, this situation. Or number of hospital beds for per 1,000 inhabitants, percentage of population provided with hospital care. Here are outpatient clinics, for instance. As you can see here, so rather everywhere is good except of one district of And in total, then we construct a healthcare accessibility index, which provides us a general information about healthcare in this very big region of Russia. In fact, in total, it is the square of this region in total is greater than France, as far as I remember. And then we construct scenarios to simulate the development of various situations. For example, what we should do if we construct here a road or add additional hospital, etc., etc., and then we process these very scenarios and evaluate the satisfaction of people in terms of these very parameters. For instance, like preschool situation with preschool services or medical care, etc., etc. And here, these are scenario technologies we might construct. Sorry, here are in Russian some. Ah, yes, sorry. The names of these regions, districts are in Russian. The current situation, this very column is like this, and according to scenario, what we will get if we change these things. Thank you very much. I think I fit to restrictions, 12 minutes, and I am ready to answer the questions. Can you hear me?
Yes, sir.
Yes,
Thank you for your
yes,
presentation.
yeah. Was good presentation. You
Thank
said
you.
about mathematical model, right?
Yes.
And
Yes.
whatever you have presented, it is all about data. So where is that
Oh,
model?
oh no, this is, sorry, let me return to the presentation. Wait a minute, where I am. No, yes, I didn't present here formulas, etc., except one thing, but generally, you see, what we do, we construct very different mathematical models, for instance, about transportation. In this very region, first time I confront with this situation, in fact, we did it for 11 regions, but here you see the roads, for instance, uh, at winter, there are one type of roads, at summer, another type of roads, and the intermediate periods in spring and autumn, the third type of roads, because you see, because of the climate, not all roads are accessible. In winter, for instance, it is also possible to use rivers, and we construct a network model. I didn't go through these details because you see, it might take a few hours, you see, to explain. But we construct the network models of different types of networks, of roads, you see, of not of roads, even of connections, which includes air connection, connection at winter by these so-called winter roads, connection by rivers at summertime and on rivers using ice cover on winter time, etc. And then we aggregate all this stuff into the single parameter of the connection between among these districts, among these settlements. For instance, it's about roads, and we have rather very interesting and very new models. But this is another story to present, and not for 10 minutes. You see.
Okay, okay, fine, fine. Okay, good presentation. Thank you very much.
Thank you.
Well, thank you for your presentation, sir. We can now move on to our next speaker. So our next speaker for today is Mbali Nkobo, I apologize for any mispronunciations. She is from the Cape Peninsula University of Technology in South Africa, and the title of her paper is Bridging the Digital Divide with Li-Fi and LoRa, Sustainable Intelligent Systems for Smart and Connected Communities. Ma'am, I request you to kindly unmute yourself and start presenting.
Hello, good morning. I hope everybody is well. So my name is Bali Ngobo from the Cape Peninsula. Oh, I'm not sharing my screen. I'm so sorry. Wait. Ooh. Sorry. Yeah, here you go. So is my screen being shared?
Yes, your screen is visible. You can start.
Okay.
Yes.
Okay. Thank you. Good morning, everyone. My name is Mbali Ngobo from the Cape Peninsula University of Technology in South Africa. So before I start off my presentation, I would like to start off with a question. So what if the light above us and a small low-powered sensor could connect the most remote rural communities to the digital world? So today I'll be speaking about my presentation, which was about the integration of LoRa and Li-Fi and how it can bridge the digital divide through sustainable and intelligent communication systems. So we will first start off with the problem. So the problem is the digital divide. So despite the rapid technological advancements, billions of people still lack reliable internet access. So according to the reports done by the International Telecommunication Union and the United Nations, rural and local communities still remain the most disconnected. So traditional systems such as cellular networks and satellite communications are powerful, yes, but they are really expensive, energy intensive, and difficult to deploy in those rural areas. So the question kind of becomes, how can we design a system that is affordable, energy efficient, secure, and inclusive? So then, instead of asking which technology is the best, this research kind of asks how can different technologies complement each other. So while live Wi-Fi provides high speed but at a limited range, cellular networks provide mobility but require expensive infrastructure, and satellite offers global coverage, but with a high latency and cost. So what we need is a hybrid approach, combining all the strengths of these technologies while minimizing the weaknesses. So then I'll talk about one of the technologies. So one of them is known as Li-Fi. So Li-Fi was introduced by Prof. Haas, which uses visible light from LEDs to transmit data. So how it works is that an LED light will switch on and off simultaneously at a extreme high speed, which is invisible to the human eye while it transmits binary data. So Li-Fi offers high data rates, strong physical security because light doesn't penetrate through walls, no radio frequency interference, and energy efficiency since light and communication happen simultaneously. So in simple terms, every LED light bulb can become a wireless router. So Li-Fi is usually ideal for hospitals, classrooms, clinics, offices, and secure indoor environment. So another technology also known as LoRa, which is supported by the LoRa Alliance, is designed for long range and low power communication. It can also transmit 15 to 20 kilometers in rural areas, and it consumes very little power, allowing the devices to operate for years and years on small batteries. So LoRa isn't designed for high-speed streaming. Instead, it is optimized for small packets of data over long distances. So it kind of makes it ideal for agriculture, environmental monitoring, rural health monitoring, and smart city sensors. So essentially, Li-Fi will focus on the speed, while LoRa focuses on the distance and efficiency. So now we were going to look at the hybrid model. So the core contribution of this research is the integration of these two technologies in a layered architecture. So in this model, Li-Fi operates at a high-speed access layer, while LoRa functions as a long-range backbone layer, while using AI, also known as artificial intelligence, which acts as an optimizing layer. So AI techniques such as machine learning for traffic prediction, fuzzy logic for handling uncertainty, and genetic algorithms for energy-aware routing allows the system to kind of adapt dynamically. So the system just doesn't become connected, but it becomes intelligent. So the hybrid model also addresses the three major research gaps. One of them is limited studies on LoRa and Li-Fi co-deployment, minimal AI-driven optimization in hybrid systems, and lack of sustainability-focused architecture design. So then we will look at the real-world applications. So what I focused on is what I first introduced was healthcare and education. So in healthcare, Li-Fi can be deployed in inside hospitals for secure, interference-free communication, especially in intensive care units, also known as ICUs. And while LoRa kind of enables remote patient monitoring in rural areas. So vital signs such as heart rate and oxygen levels can be transmitted over long distances using minimal energy. Then we go on and go into education, which is aligned with the Sustainable Development Goal 4 from the United Nations, also known as quality of education. So Li-Fi enables smart classrooms and digital libraries, while LoRa provides connectivity to rural schools where broad bandwidth infrastructure does not exist. So essentially, this ensures that the access to education does not just depend on the geography. Like I mentioned at the bottom, that a rural child should have the same digital opportunity as an urban child. Here we go on and look at it in terms of smart agriculture and smart cities. So in agriculture, LoRa connects soil monitoring systems, the weather stations, livestock trackers across large farmlands, while Li-Fi can support the greenhouse monitoring systems. And a solar-powered LoRa gateway will be combined with the LED-based Li-Fi, which can create a sustainable ecosystem for smart farming. So then we go on and look at the smart cities. So Li-Fi can enable secure government communication and smart buildings, while LoRa kind of supports the flood detection, air quality monitoring, and waste management systems. So together they can create a scalable and energy efficient infrastructure. So now we'll go on and look at the challenges. I don't have the challenges here, but I'll speak about them. So of course we have challenges. So while Li-Fi requires a line of sight and dense LED infrastructure, LoRa has a limited bandwidth. Then the security must be strengthened through the robust encryptancy and key management, and the standardization of Li-Fi is still evolving. So, however, these are engineering challenges, but it's not impossibilities, because similar obstacles existed during the early deployment of Wi-Fi and cellular devices. So then we go on to the contributions and the future direction. This research proposes a theoretical hybrid LoRa and Li-Fi architecture, an AI-enabled resource optimization, a green computing integration, a cross-domain deployment model, and alignment with the Sustainable Development Goals. So the future works also include the pilot deployments in rural schools and clinics, solar-powered gateways, solar-powered implementation of gateways in those rural areas, real-world performance measurements, and the advanced AI bandwidth allocation. So to conclude my presentation, I would like to mention that Li-Fi and LoRa are not competing technologies, but they are complementary technologies. So when integrated intelligently, they can provide high-speed indoor access, long-range rural coverage, energy efficient communication, and sustainable and inclusive digital ecosystems. So this is not only just about connectivity, but it is about digital equality. So the future of communication is just not going to be much more faster, but much more fairer. Thank you so much.
Thank you for your presentation, ma'am. Dr. Pathan, do you
Thank
have
you.
any questions for our speaker?
Yes. Hi, Balim.
Hi, sir, how are you?
I'm fine. How are you?
I'm good.
That's good. You said about Li-Fi and LoRa, isn't it?
Yes.
Do you have any case studies which is in execution?
I'm sorry, sir?
Do you have any case studies which is in execution or which is live one?
Oh, so I read about one case study that has implemented Li-Fi. It's one of the European countries where Li-Fi has been implemented in the classrooms, where the students can be part with the digital libraries and also have smart boardrooms and smart, they can be in the smart classroom, yes.
Acha. Because for Li-Fi, there we are years from more than 10 to 20 years we are discussing, but I have not gone through a case study or live case study where it has been executed. Now, if that is the case, we need to understand the feasibility of it.
Okay.
Hmm. And second, you said about LoRa, isn't it?
Yes, sir.
Acha. My next
So I
question
would
is,
like, sorry, sir,
yes.
I would like to also mention that I'm an undergrad student. So some of these scopes, I'm still trying to research more about them and learn more about them, especially Li-Fi, in terms of Li-Fi.
Acha. Now that is fine. Now, if that is the case, it whatever presentation you have given, it talks about technology.
Yes.
I would like to understand what will be your contribution in this case as a researcher.
Sorry, sir.
What is your contribution in this case?
Can
What
you please repeat?
you wish to propose using this Li-Fi technology?
What is my
Your
proposal?
proposal. Yeah, yeah, yeah.
Yes. So I would like these technologies to be implemented in those rural areas. Since in rural areas we don't have much communication going on due to the fact that they're not able to access the internet and don't have the cost for it. So I'm trying to approach it in a much more smart technology way and a much more greener and better way for them to be able to connect to the internet and use these technologies in the future.
Okay, lovely. Good presentation. Wish you all good luck.
Okay, thank you so much, sir.
I'm concluding here.
Thank you.
Thank you for your presentation, ma'am. We can now move on to our next speaker. So the name of our next speaker is Manut Tanticharan. I am really sorry for the pronunciation. From the Sirindon International Institute of Technology in Thailand. And the title of his paper is Data-Driven Inflow Forecasting for Dam Safety Monitoring Using Local Meteorological Data. So I request you to kindly unmute and start presenting.
Hello. Do you hear me?
Yes, sir, you're audible.
Is my camera open or not?
I don't think so, sir. We are not able to see you.
Oh, wait. Why is my camera not working? Can you see the presentation?
It is still loading, but I think
It's
it has
still
started.
loading?
Yeah, we can now see it.
Okay. I wonder why my video is not on.
It's totally fine, sir. You can start presenting.
Okay. Let me Start everything. Boop. Okay. Hello, everyone. My name is Munatanti Charan, and today I'm going to be presenting my paper, Data-Driven Inflow Forecasting for Dam Safety Monitoring Using Local Meteorological Data. I'm a student from Siddington Institute of Technology, and this is my presentation. So let's start off with the overview. This presentation will include the introduction, the data, motives, models, proposed method, evaluation, result, and then lastly, a conclusion. So now let's talk about the motives and our objectives. So dam failure is consequential. Dam failure can cause a lot of harm to a local nearby area. So I was tasked with an objective to create a better system than the system called DSRMS, which is my old colleagues' older way to predict dam inflow. So DSRMS is used to accurately predict the dam inflow, but it needs a highly accurate inflow and it needs a seasonal pattern like rain season in my country of Thailand. Now, for me, I'm tasked to create a new one. I will be using deep learning and plus non-sequential based model is proposed to utilize daily local meteorological data to accurately predict inflow. So does meteorological data from my local area improve the prediction? So let's talk about the data processing. So there's two dam data. Two of them are from Ubon Ratana Dam and Hue Kum Dam. So Ubon Ratana have 3,990 samples from January to August 2024. Hue Kum have 3,429 January to June 2025. So these two data have 7 features. These are the features listed below, and this is the inflow model. So before we put it into the model, I interpret if the data is missing, then convert the value to an appropriate metric. So let's look at our models. This is ARIMA. This is our baseline because it's a time series forecasting using past data to predict the next future data, which is perfect because we want to see if this is good or bad or not. Now, some results can lead to negative values. So I put my friend and we created a pseudo ReLU for this specific model. So if it goes like a negative number, we turn it to 0, which is a lot more clean because inflow, inflow is a positive number, not a negative one. And then we also use deep learning, which is a multi-layered structure. So we could see some complex data, such as a unpredictable rain inflow, stuff like that. And then we have 3 models that is in deep learning, which is FCNN, RNN, and LSTM. So when we first tried to do this research, we expect FCN to be a non-temporal and a non-linear model, so it doesn't affect by time. It's mostly affected by direct learning. RNN is for sequential data. It's a bit short. It's fast to run. It's simple. And the third one is LSTM, which is similar to RNN, but we could record longer data, avoiding vanishing gradient, and can capture long sequences of that data. So from the picture, we have FCN, RNN, and LSTM. LSTM takes a bit of a while to process. So let's see which one is good. But from the next part, I want to go to a proposed method. This is our proposed method. We've been trial and error for a good proposed method. So we have our input vector, which is a six featured input vector. We put that into our model, which is a 64-unit ReLU activation function, and then 32-unit ReLU activation function, 0.4 dropout, density of 1, so we could get an answer, and then that will output the predicted inflow from this ML model right here. Dropout is for if there is any like errors and stuff like that. 64 unit and 32. Then the X part is the deep learning model like RNN, LSTM, and stuff like that. Dropout is for randomizing values so the machine can actually learn something. Now, let's talk about our evaluation and results. Now, let's talk about our evaluation first. So in this very simple model, we'll be using 70% training and 30% for testing, min-max normalization, Huber loss for decrease in sensitivity, batch size of 64, true success half-set of 30 days, because we want to predict a month earlier, so use 30 days. And then for direct teaching, we also add direct teaching into the input. We call this engineering input inflow, which means that our local data might do better at least. And then our evaluation would mean squared error and Pearson correlations, which is in here we call it CC. This is just our small example right here. Now, let's talk about our evaluation and results. The first one will be Ubon Ratana Dam. As you can see here, we have ARIMA, which is our baseline, which is at the top. We also have FCN, RN, and LSTM. Now, for what I have to say, RMSE could be anything, right? We need a baseline for our RMSE. We don't know how much error we have or how much differentiate between the predicted value and the actual value. So we baseline is 4. So if it's bigger or smaller than that, there is a problem. In here, we have a fine-looking model. We divide it into 3 sections: only inflow, only meteorological data, and inflow plus meteorological data. Only inflow is the direct teaching method. Only meteorological data is our local data from the dam itself, from the recorded dams. Then inflow plus meteorological data is direct teaching plus the local data that we gathered. Then we put it into our model. So as you can see here, we can see that FCNN does a lot better if it's direct teaching, which is obvious. If there is no direct teaching, RNN and LSTM can do a lot better. But even if we use both of them, FCN is still kicking because the inflow is, we still have direct teaching in there. So of course it's going to do a lot better. Now for the Hue Kum Dam, we have same sets, but the results are a bit different. I will be talking about why Hue Kum Dam is not reliable. As you can see here, RN dominates, even though RMSE is a bit, RMSE is pretty low. In here, Hue Kum's RMSE is base of 1, so there's not much big values in here. Correlation is dominant for RNN, but if we combine inflow and meteorological data, that means FCNN could do a lot better here, even though the correlation values is extremely low. I'll be talking about why in a second. Conclusion. Now, from what we gathered, local meteorological data improves our inflow forecasting. Models benefit from their teaching methods such as FCNN can beat ARIMA, while meteorological data benefited for deep learning models. So if we don't direct teach that, RN and LSTM dominates. So as seen in results, both they have different seasonal patterns. Hue Kum Dam have no seasonal patterns. That's why the results are extremely, extremely bad. The droughts over there is it's super hot in there. So you experience droughts, unpredictable patterns of weather. It's in Isan. That's where the dams are like drought a lot. There's still water, but there's not much rain. So there's some limitations. We can improve this data by having longer range of time into even decades. more variables such as store permeability and interpretation of data by seasons, which I think will improve this a lot more speciality for our data. And thank you for watching.
Thank you so much for your presentation, sir.
Yeah.
I request our session chair if he has any questions for our speaker.
Yes, please. May I ask a question?
Yes.
Sure, sir.
Yes. 1 minute. Hi, Manu.
Did you publish these very results already?
Yes, I already published this paper with the results, yes.
I will be happy to get it. If you wish, I can write my email in chat.
Yep.
This is the first thing. And second thing is that it might be also useful for you. Some time ago, we created a very serious technique to analyze such kind of data, and we applied it for tornado prediction and got the best results ever obtained, 61% of accuracy. It was published in Springer Nature and several top journals. So this might be interesting for you as well. I can send you the article.
Thank you so much.
Yeah, just send me email.
Yep.
Send me your article by email, but I cannot understand how to. Okay. I will write my email address, and then I will respond to your email, sending you the article. Okay. Okay. I wrote my email address. And if somebody else is interested with this very results published concerning tornado prediction, I will be happy to send. Okay.
Okay.
Thank you very much.
Thank you. No problem. Okay.
Dr. Pathan, do you have any questions for our speaker?
Yes, Mo.
Yes, sir. Go right ahead.
First of all, very good presentation. 1 minute, let me start my camera also. Very good presentation you are given.
Thank you so
You,
much.
you are saying about data-driven model, isn't it? So what about validation of the model? How you are
Validation of my validation of my model.
Yes.
For this model, I only have a training and a testing. We don't have a validation for control models.
No. Training and testing is for input to the model. After execution, you need to validate it. Whatever results are coming, that are correct or not. So have you applied any method for validation, or have you done any validation, even mathematically also any validation you have done? Technically also any from technological person you have done any validation? That was my question. That is my question.
Do you mean like validation testing? For this paper, we didn't like have a validation testing.
Validation of model, whatever model you have presented.
Oh, you mean my model here?
Yeah.
My proposed method is over here for my workflow. This is my model. Yep.
So it is about model, Manoj. I am asking about validation of this model.
We have a lot of trial and error to see which of the models can actually work the best, and we decided to choose this model because it runs pretty good. It doesn't inflate my numbers a lot. That's why we use it. Yes.
Acha, okay. It is all from my end, Manoj.
Yep. Thank you so much.
Wish you all good luck.
Thank you.
Well, that was a great presentation and also a great bit of networking. Well, we can now move on to our next speaker. So our next speaker is Zachary Matthew Alabastro from the Ateneo de Manila University in the Philippines and the title of the paper is A Large Language Models and Jobs to be Done Framework in Customer Validation for Product Managers. So I request you to kindly unmute and start presenting.
Thank you. Hello, everyone. Good morning. Allow me to share my screen first. All right. Good morning, everyone. My name is Zachary Alabastro, and I am from the Ateneo Business Insights Laboratory for Development at the Ateneo de Manila University. Today, I'll be presenting our study entitled Large Language Models and the Jobs to be Done Framework in Customer Validation for Product Managers. This work explores how we can use AI, specifically large language models, as synthetic customer agents to support early-stage product validation, grounded in the Jobs to be Done framework. So let's start with the problem that every product manager faces. Customer validation is one of the most critical activities in product management. Before you build, before you invest, you need to understand whether your product actually solves a real problem for real people. But here's the challenge. Conducting proper customer validation is constrained by time, scale, and by limited access to diverse customer perspectives. According to literature, product failure more often results from a misalignment between a team's assumptions and customer realities than from technical limitations. The product works, it just doesn't solve the right problem for the right people. So how do we bridge the gap more efficiently? This is where the Jobs to be Done framework comes in. JTBD flips the traditional approach to customer research. Instead of asking what features do customers want, it asks what job is the customer trying to accomplish. The framework focuses on 3 dimensions. First, the functional dimension. What task does the customer actually need to get done? Second, the emotional dimension. How does the customer want to feel during the process? And last is the social dimension. How does the customer want to be perceived by others? JTBD operationalizes this through job stories and outcome-driven interviews that foreground circumstances, constraints, and desired outcomes. Now, prior research also shows that effective JTBD practice depends less on the framework itself and more on the practitioner's ability to sustain job-oriented questioning, specifically for novice product managers. Our study is guided by 2 research questions. First, how do different large language models generate and structure synthetic customer responses and JTBD-oriented questions under controlled prompting conditions? And second, what design considerations and constraints emerge when integrating these LLM-generated synthetic respondents into a JTBD-based training tool? An important framing note: this is a design-oriented study. We treat LLM outputs as exploratory design artifacts, not as empirical representations of real customers. We're following the Homo silicus framing, where synthetic agents serve as bounded cognitive proxies, not substitutes for real-world research. So we built the simulation-based system using Python and a Django framework that integrates 4 different LLM engines: OpenAI's GPT 5.2, Anthropic Claude's 4.5 Sonnet, Google's Gemini 3 Pro, and Mistral's DevStral 2. On the left, we have the inputs, product attributes including name, price, category, serving size, months until expiration, a description, and value points. The user also specifies the sample size of these synthetic agents. Next, these inputs are passed to the selected LLM engine, which processes them through our Python framework using function calling and JSON parsing. The LLM then generates what we call an accumulated context, a sample set of customer agents with attributes and willingness to pay signals. This creates a hypothetical customer discovery environment with preliminary data. Finally, the accumulated data is used by the LLM to generate JTBD-focused questions that can help coach product managers during the design process. So the key design principle here is really hierarchical prompting. Each stage builds onto the previous one, maintaining internal coherence. So step one is persona generation. Using prompt chaining, we generate structured JSON personas with both demographic attributes like age, income level, and education, and psychographic attributes such as buying motivations, shopping methods, and health consciousness. The prompts are designed so that attributes are internally consistent. Step two is simulated feedback. This is where the personas come alive through simulation of group discussion, where each synthetic agent is assigned JTBD-aligned contexts, operational constraints, and task ambitions. Each agent produces a willingness to pay signal through yes or no, paired with a qualitative justification explaining why they would or would not hire that certain product. And step three is question synthesis. The personas and their feedback are reintroduced to the LLM under an explicit JTBD framing. The model then generates a categorized set of customer validation questions that link specific pain points to validation strategies. These are the questions a product manager could use in actual customer interviews. So here's a quick example of a synthetic customer persona generated by the Anthropic model. This table is one of the core results of our study. It compares the 4 LLMs across 4 dimensions: persona fidelity, JTBD alignment, response structure, and question depth. Starting with Claude 4.5 Sonnet, it produced what we call a value-driven persona. So the agents frequently declined to hire the product when attributes conflicted with personal values like health consciousness or transparency. Its questions were psychological and values-oriented. GPT 5.2 took a more pragmatic approach, with balanced personas that weighed convenience against health concerns. Its questions were more practical and focused on decision triggers. Mistral DevStral 2 showed the strongest persona fidelity, the tightest consistency between the demographic variables and their stated motivations. Its responses were brief but utilitarian. Gemini 3 Pro was the most situationally dynamic. It highlighted acute triggers like hunger and budget constraints as the primary hiring drivers. Notably, it also incorporated localized Filipino language, such as the term pantawid gutom, which translates to passing over hunger. This was the most culturally contextual output made by the model. The key takeaway: all 4 models generate usable preliminary insights, but they exhibited distinct structural and stylistic tendencies that reveal how different architectures operationalize the same framework. Claude displayed what we called a principal rejection pattern. So its agents were more likely to say no and give elaborate reasons that tied to their personal values and anxieties. GPT 5.2 was the pragmatic trade-off model. Mistral had the strongest internal consistency between the attributes and the responses. So if your priority is more on demographic realism, this model excels in that. And last, for Gemini, it was the most dynamic and culturally aware, picking up on the local context in ways that other models were not able to actually do. So these are more of behavioral profiles, and the right model choice really depends on the specific validation objective of the user or of the product manager. Now, moving to our second research question, what design considerations emerge from this framework? First is prompt constraints. The quality of the output depends heavily on the prompt structures that stabilize context and keep product attributes the primary decision variable. Without this, the models tend to generate generic marketing commentary rather than actual specific insights. Second, explicit JTBD scaffolding. You need to build the framework's logic directly into the prompts. If you just ask the LLM to act as a customer, you'll get surface-level responses. The prompts must enforce job-oriented reasoning. And third, human-in-the-loop oversight. Product managers must still contextualize and refine the AI-generated questions using real-world signals. LLMs have knowledge cutoffs. They lack emotional grounding, and they cannot replace lived human experience. So our central finding is that LLMs can serve as instruments for workforce augmentation in the JTBD-oriented customer validation framework, but not as professional displacement. The system automates synthesis while preserving the product manager's essential role in interpretation and final decision-making. Our study makes three key contributions. First, we developed a design and prompting framework for JTBD-oriented synthetic customer simulation using different LLM architectures. Second, we provide descriptive insights into how different models behave in customer validation contexts. These are insights that are directly relevant for the actual tool's design. And third, we articulate design considerations and boundary conditions that clarify when and how synthetic respondents should be used in market research training. Again, we want to be clear. These outputs should be treated as high-quality templates for minimal refinement, but not as complete substitutes for actual customer research. Looking ahead, we also have 4 directions for future work. First, we plan to evaluate additional open source and lightweight models that could make this approach more accessible in resource-constrained areas, particularly for startups in emerging markets. Second, we want to adapt the prompting strategies for B2B contexts, which have fundamentally different decision structures than B2C products. Third, we're exploring multimodal pipelines where different LLMs handle different stages of the entire process, leveraging each model's specific strengths. And fourth is empirical validation. We need to compare our simulated outputs with real customer data to estimate the semantic distance between what these synthetic agents say to what actual real customers think. And with that, I'd like to thank the John Gokongwei School of Management, Ateneo Build, and the University Research Council of the Ateneo de Manila University for supporting our research. Thank you for your time and attention. I'm happy to take any questions.
Yes, Zuchare, I'm sorry if I have not pronounced well. You said about LLM. What are the other application, whichever application you have said, which may be the other application?
Aside from jobs to be done framework or asking questions, again, it can also be used for creating these questions for deciding where else or what else, what kind of customer segments could also be looked into. So because of the knowledge or the capability that it has on both its context and on what the product is or what customers could potentially think, it could give new insights about what other possible target markets, what other possible products could be produced or could be used when getting out of the building or when looking for more areas to improve on for that business.
Okay, Zuchare, nice presentation. Wish you all good luck for your future research.
Thank you very much.
Thank you for your presentation, sir. We now move on to our next speaker. Our next speaker is Kondratenko Stanislav. I apologize for any mispronunciations. From the ITMO University in Russia. And the title of his paper is Methodology for Quantitative Assessment of IoT Device Security in Critical Infrastructure Based on Attributes. So I request you to kindly unmute yourself and start presenting.
Hello, everyone. Now I'm sharing my presentation. Okay. All okay?
Yes, sir, you can begin.
Yes, okay, thank you. Good day, everyone. My name is Stanislav, and today I will present our paper, Methodology for Quantitative Assessment of I/O Device Security in Critical Infrastructure Based on Attributes. Our main idea is simple. If we want realistic risk estimates for IoT and critical infrastructure, we must go beyond static vulnerability scores, and account for how devices actually operate under changing conditions and within a specific environment. Critical infrastructures, energy, transport, industry, and healthcare are rapidly integrating IoT devices for automation, remote monitoring, and efficiency. But every connected device expands the attack surface. In critical environments, the impact is not just data loss. It can mean power outage, traffic disruptions, industrial incidents, or in healthcare, direct harm to patients. A major challenge is that common security and risk metrics often emphasize static information like known vulnerabilities and their severity while underrepresenting operational context. In practice, the probability of compromise depends strongly on conditions such as network stability, power quality, or the device's current operation state. The objective of our research is to develop a universal methodology for classifying IoT device attributes and for quantitatively assessing their security in critical infrastructures. We validate the methodology in healthcare, specifically IoMT, because in this domain, compromise can affect human life. Devices are highly interconnected, and there is extensive public data on vulnerabilities and incidents. Our contributions are threefold: a three-level attribute classification, static, dynamic, and contextual, an extended security coefficient called K-security that integrates these attributes with attacker vulnerability, impact, and network factors, and an experimental validation using Monte Carlo simulations and a GNS3 based testbed with emulated IoMT devices and attack scripts. Let me explain the attribute model because it is a backbone of the methodology. We define three categories. First is static attributes, mostly fixed characteristics determined at design or manufacturing time. The next one is second, dynamic attributes, real-time operational parameters. And the third, contextual attributes, factors outside the device but shaping its security in reality. The key message here is that security is not only a device property, it's also a property of operation and environment. For quantitative assessment, each attribute is normalized to a 0 to 1 scale using practical interpretation rules. Values represent levels from poor to strong conditions. Then we define three operation scenarios to represent real-life conditions: optimum, standard, and extreme. Now, the metric. We build on the previously introduced idea of security coefficient and extend it by multiplying in the attributes groups. In the denominator, SEC aggregates threat agent factors, vulnerability factors, impact factors, network distribution factors, attribute factors. We choose the medical sector for validation because it is one of the most representative critical infrastructures for security research. Compromise may directly affect patient safety, device from integrated ecosystems, and vulnerability databases, and incident records are compromisingly rich. For experiments, we deployed virtualized network environments in GNS3. We internationally use a flat network topology without VLAN segmentation or perimeter firewalls. This represents a worst-case assumption: the attacker already breached the perimeter or is an insider, and we want to measure the device security without external controls masking the results. The topology includes one core switch, 10 IoMT devices, and one attacker node running Kali Linux. Each IoMT device was emulated on OpenVRT, chosen for its lightweight embedded Linux similarity. A startup and initialization script configures vulnerability or characteristic services and ports, banners and responses for realistic identification, Initialization is static, dynamic, and contextual attributes that influences attack probability. For validation, we ran an automated attack workflow, recognized with scanning, explanation with modular scripts, and most importantly, probabilistic success. The links the mass model directly to the emulated network behavior. Along the experiments, we use Monte Carlo stochastic modeling to estimate the probability of compromise. We ran 2,000 iterations per device per scenario with 10 devices and 3 scenarios. That total 60,000 simulations runs. We separated parameters into scenario fixed attributes, stochastic factors, and a noise factor to capture empirical real-world benches. Key results, CVSS was with real compromise. A major result is a mismatch between formal vulnerability severity and actual probability. Common methods like CVSS and WAS classify many devices as high or critical risk, often above 60% severity because they reflect known vulnerabilities. But both our Monte Carlo calculations and our GNS3 experiment show that actual compromise probability falls roughly in the 5% to 22% range, depending on the device's scenario. We also studied which attribute groups matter most using sensitivity analysis with regression on sampled scenarios we found. Dynamic attributes and contextual attributes have the stronger influence and are statistically significant. Static attributes show the weakest contribution, and their significance was not statistically proven under noisy conditions in our analysis. In practical terms, this means that what the device is matters, but how it is running right now and what environment it is in often matter more. In our conclusions, 3 factors stand out as especially critical: network connection quality, power and resource stability, and in IOMT, philosophical parameter critically and monitoring. Our methodology supports priority under constrained resources instead of treating all critical CVS as actually urgent. Teams can quantify how operating conditions shape actual risk and then invest where the risk reduction is more effective. For healthcare, the model helps justify investments in monitoring and improving network scalability for IOMT segments, ensuring backup power and power quality, and enforcing controls that maintain truly dynamic operations like anomaly detection on device states and vital sign streams. We proposed a universal quantitative methodology for assessing IO device security in critical infrastructure by combining a 3-level attribute classification with an adapted security coefficient K security. We validated the approach in the medical domain using 6,000 Monte Carlo simulations and GNS3 experimental testbed, and we demonstrated that contextual and dynamic factors dominate real compromise probability, while traditional severity scores can substantially overestimate actual exploitation likelihood. Future work can extend the model by incorporating real segmentation controls like VLANs, IDS, IPS effects, and richer attacker profiles, and by adapting consequence weighted to other sectors such as energy and transport. Thank you for your attention. I will be happy to answer your questions.
Thank you for your presentation, sir. I request our session chair if he has any questions for him.
Hi, sir. Hi.
Hello, hello.
Yeah. You are saying about IoT device security. Any specific protocol you are talking about? Can you tell me any specific protocol for IoT?
Basic protocol. Yeah. We're not based on protocols. Yeah, we based on the main concept for coefficient of security for the model of IoT devices, which based on attributes, static, dynamic, and context. And protocols, we can use any of that, MQTT and something like that.
Acha. And whatever measure you are taking for device security, so have you considered any constraint for security algorithms? Any constraint for security algorithm? Huh?
Okay. We use Monte Carlo, as I said, yeah, for the approach, yes, and it depends on our case with any groups of the attributes, but maybe I cannot catch your question about an algorithm, yeah?
Okay, fine. Wish you all good luck. Thank you.
Okay, thank you so much.
Thank you for your presentation, sir. We now move on to the last presentation for this session, which will be done by Maki Arame from the Polytechnic University of Japan. And the title of the paper is Support Strategies in Driver Safety Education Based on Relational Learning Assessment, a focus on advisory behavior. Ma'am, I request you to kindly unmute yourself and start presenting.
Thank you. Okay. Can you see the presentation?
Yes, ma'am, the presentation is visible. You can start.
Yes, you
Thank
may.
you. Thank you for the kind introduction. Good morning. My name is Maki Arame from the Polytechnic University of Japan. It is a great honor to present our research today. This research is being conducted under the direction of Professor Yoshiko Goda of Kumamoto University. Here is the structure of today's presentation. I will begin with the background, then explain the purpose of methodology, followed by the result discussion. In Japan, drivers are aging rapidly. The average age of license holder now exceeds 15 years, and the number of drivers aged 19 and over has surpassed 100,000. This demographic shift raises important safety and mobility concerns. To address safety concerns, Japan has shortened renewal period of older driver and introduced cognitive testing. This is also a volunteer license surrender system. However, surrendering one's driver license is rarely a purely personal decision. It is influenced not only by close relatives, but also by the expansion and public opinion society. Driver assistance system, abbreviated as DAS, are becoming increasingly sophisticated. Traditionally, they were convenient but not essential. Now they are becoming independent for vulnerable drivers. Our team believes drivers must learn to choose the support they truly need. As automated driving technology continue to advance, DAS are expanding their role from supplementary tool for able to indispensable system for transport voluntary population, including people with disability. For example, self-driving dependent not only on visual acuity but also sufficient on the visual field, and DAS designed to compensate for or expand the driver's field of view are currently being developed. When systems become essential, this trust emerges. Driver must entrust their lives to technology. The traditional issue was over trust. Now this trust becoming a new challenge. Hoff and Basha describe trust as dynamic and multi-layered. Trust consists of three components. One, disposition trust. Two, situational trust. And three, learned trust. The key insight is that trust is shaped by environmental condition and the quality of interaction. Our broad goal is to understand how drive can recognize their own ability and learn what assistance they need, especially in the future subscription-based DAS environment. Against this background, we first reviewed previous research to identify the main challenge facing driver safety education. Our team has previously investigated voluntary surrender of driver's license and perception of one's own driving. Importantly, perception is not formed in isolation, but through relationship and environment. In Japan, this communication, which aims to reduce the damage caused by nature disasters such as earthquakes, flood, and typhoon, emphasizes the importance of effective transmission of risk information and dialogue among stakeholders. No matter how much information is provided, it will not lead to disaster mitigation if residents don't understand it and know how to act. For example, instead of just showing them the number, tell them how to act in them. In disaster education, simply providing information is not enough. Dialogue and trust building are essential. Evaluation focused not only on outcomes but also on relationship process. This study examines advisory behavior from relation perspective. We focused on how close relative activity of the drivers. We surveyed 312 respondents aged 40 to 60 who have elderly driver among their close relatives. The survey asked respondents about their age, relationships to close relatives, and resilience. This is the yellow part. For the respondents' close relative, questions were asked about Question 1, driving characteristic. Question 2, function decline in the close relative that the respondent was aware of. Question 3, driving frequency. Reflecting the age distribution of all the drivers, respondents were organized gender by age category. This table summarizes the respondent's resilience factor score. Comparing respondents in parent-child relationship, abbreviated as PCR, those with those in other relationship. The mean score for PCR was significantly lower. The table shows the result of selecting the physical and mental change that respondents have noticed in their close relative. Approximately 18% of respondents reported noticed some form of function decline in the older driver close to them. Among close relatives, 79.4% of respondents PCR have noticed change, but only 65.5% of offer advice. It shows that awareness doesn't automatically lead to action. Logistic regression. Among 309 respondents, 180 engaged in advisory behavior. Advisory behavior
Excuse me,
was
ma'am.
possibly... Hi?
I'm
Yes?
really sorry to interrupt, but 10 minutes are up and you have 2 minutes of presentation time left.
Okay, thank you.
Thank you so much.
Driving frequency shows negative associate. Additionally, results indicate that perception of reduced reaction time was the primary balancing variable, followed by fortune-oriented resilience 4. Subsequent balancing occurred depending on the type of relationship. Recognize of reduced reaction speed was the primary balancing variable. This shows a hierarchical structure. This risk recognition first, then psychological readiness. This decision tree is acceptance advice. For acceptance advice, driving frequency was the main factor. Resilience didn't appear. This means generating advice and accepting advice are different process. Discussion. Advisory behavior doesn't arise automatically from risk cognition. It emerges through interaction between risk perception and psychological readiness. Safety education should therefore be relation, not one direction. Limitation and recommendation. First, technology alone is not sufficient. As AI-based supporting increase, dialogue and trust-based interaction remained critical. Conclusion. As driver assistant technology and AI continue to evolve, further examination of the relational process in current driving behavior is necessary to promote safe and sustainable driving habits. Thank you for your attention.
Thank you so much, ma'am. Dr. Pathan, do you have any questions for our speaker?
Hi,
Hi.
Maki.
Yes.
You are using any artificial intelligence in it?
Yes.
Yes. Please go ahead.
I think my opinion is, I'm not sure, but I guess that AI is influence this driver assistant system, but now AI influence only driver, but in future maybe close relatives if is important.
Acha. Because it will help you to analyze data more
Yes.
effectively. More effectively.
Modify.
Yes. Right. So good presentation, Maki.
Yes.
Wish you yeah. Wish you all the best. It is all from my end.
Thank you. Thank you.
Thank you so much for your presentation, ma'am. And that brings us to the end of this particular technical session. I now request our session chair, Dr. Shafi Pathan, if he has any closing remarks for us.
Yes, first of all, I'm really thankful to Amok because he has nicely carried out all these things, and it was like a smooth journey for all of us, for session chair also and for all the presenter also. The research paradigm the presented in this presentation was from quality living to driver safety, and that is what real research means. It is said that the real research will be that research which will be helpful to the society rather than talking about numbers and all these things. So if that is the case, and that is what it is expected in India, that is what our national education policy in India it says about, that it should be an inclusive research which will be directly helpful to the society in all possible way. And we are very happy to see here that these things are followed here, like how things can be a good or how things can be a helpful to for human uh, safety as well as human living. Along with that, some research is presented about LLM also, large language model like things, which makes the things in represent in an optimized way. So that is good part of it. So one and all, it is good to see that things are moving in in going very good direction, and at the same time the organization like GR Foundation and Springer Nature, they are helping this thing to happen in a correct place and in a right way. At the end, I will like to once again thank you, Mr. Amit Joshi sir, conference chair, for showing confidence in me, and our my own friend Niranjan Day for being with me in all research possible journey. I congratulate all the researchers for their research, and I wish all them good luck for their future research. So thank you, one and all.
Thank you so much, sir. I would like to sincerely thank all of our authors for their excellent presentations and contributions in this session, and also all of our participants for being a part of this international conference. I hope this session was informative enough for all of you. And we, on behalf of the entire team, thank you for your support during this 11th version. And we will be more than happy to host all of you once again for the 12th edition in 2027. Just a small announcement. All the presenters would be getting their digital certificates via email within 2 working days, and the publications will be live within 7 to 8 months. So kindly cooperate with the team of ICICT 2026. Once again, I would also like to thank our session chair, Dr. Shafi Pathan, for chairing this session. This is just a small token of our appreciation on behalf of the team of ICICT 2026. Just a small request. I would request all of you to switch on your cameras so we can have a snapshot of this virtual conference. And we're done. Thank you so much, everyone.
Okay. Thank you very
Yes.
much.
You're very welcome, sir. Thank you.
Thank you. Thank you
Thank
very much.
you.
Bye bye.
Bye bye.